2.6. Let's see, substitutions and transformations. So we're gonna study how to solve differential equations that are not the cases, the forms we have studied in 2.1 to 2.5. Okay, so homogeneous equations having the form the dy dx equals a function of y or x. Okay, so let's start with that type. Okay, so we're gonna go I try to go through type 1 through type 4. Okay, so the first type is homogeneous equations. The main idea is to transform the homogeneous equation to separable using the change of variable, okay, as v equals y over x. Okay, let me give you an idea how to find out solution of the homogeneous by solving equation example. Okay, so example. Okay. So let's see 2xy and dy is equal plus x squared minus y squared and dx equals 0. The step 1 is to identify the type of equations. Okay. So let's try to identify the type of equation. Is this separable? Okay. Then it's kind of straightforward to figure out that this is not separable. So this is not separable. Why? Because we cannot separate the function of x and y in the right hand side when we rewrite this one as dy dx. See, dy dx is equal to what? Y squared minus x squared over 2xy. So as you can see that we can separate them. This is exact. The answer is actually yes. This is exact. So what is m? M of x comma y is x squared minus y squared. And then n x comma y is 2xy. Right. And then partial m, and the partial the y gonna be minus 2y, right? And then the partial n, oh, give me a second. Partial and partial y. Oh yeah. This is the answer is real no, right? The partial n, now partial x is gonna be 2y. Okay, so they are not exact. The linear, yeah, it's not linear because of y squared term. So, is this homogeneous? The answer is yes. Why? Let's figure out f of x comma y. So dy dx is equal to this one, right? Y squared minus x squared over 2xy. So that's the f of x comma y. Right. So we need to see if this guy is equal to f of tx comma ty. Okay. If this is equal to that, it means that that differential equation is homogeneous. And f of tx comma ty is equal to ty squared minus tx squared, which is t squared, right? times y squared minus x squared over the 2t squared, right, times 2xy. So this is equal to what? F of x comma y. For any t, it's just not equal to 0. Okay, so that's why this is homogeneous. Now step 2, express the differential equation. In the derivative form. We already got it, actually. dy dx is equal to f of x comma y. Okay. So rewrite f as a function of y over x alone, which means that we need to get a g over y over x. That's a step 2. Okay. And rewrite f of x comma y as a function of y over x alone. So y dy dx is the y squared, or let me just leave a negative sign. Okay. X squared minus y squared over 2xy. This is equal to minus. To get the rewrite this one as function of y over x, we need to divide top and bottom by x squared. Okay, so here you see we just multiply top and bottom by 1 over x squared times 1 over x squared, right? Times 1 over x squared. So then we're gonna get minus, and then 1 minus y over x squared, right? Over just 2 times y over x. See? So we can say what? This is, let's say this is a g of y over x. Now step 3, let's substitute a new variable into y over x. And solve the transform the differential equation. So let's say v, this is v, okay? V is a y over x, okay? Then dy dx is going to be minus. You take a derivative, the v is a function of x, okay? Taking derivative of y, I mean, what? From right there, dy dx is this one, right? Dy dx is going to be minus, and 1 minus substituting v into y over x. So we're going to get 1 minus v squared over 2v, 2 times v, right? So which is v squared minus 1 over 2v, right? Okay. So that is equal to v over 2 and then minus 1 over 2v. Sometimes, yeah, either way is just fine. Just you stop, rewriting up to here. That's fine. Then now what you're gonna do? We need to find out relationship between dy dx and the dv dx. So we take a derivative. We're applying the implicit differentiation into this equation to figure out the relationship between dy dx and dv dx. dv dx is gonna be right, is a derivative of this guy with respect to x, which is y prime, right? And then times 1 over x, now plus y times 1 over x prime, right? So which is y prime is dy dx, right? dy and dx. Then times 1 over x, right? And then plus and then taking not plus minus, right? And then y over x squared. Okay. So now then that is equal to because y over x is a v, right? So we can express this one in terms of v. So dy over dx times 1 over x minus, and then v times v over x. Okay, then dy dx is here. We what? Give me a second. See. Oh yeah. Okay. Dy dx. Yeah. Okay. Now then dy dx is equal to. So what we got? dv dx is equal to what? This one, right? But we want to find. We want to express. We need to express dy dx in terms of dv dx. So I'm going to isolate dy dx by moving this stuff to the left-hand side. And dy dx is going to be x times, this guy, and then plus v, right? So x times, then dv dx, right? And then plus, right? Second, and then v, right? Let me see. So we could express dy dx as like this. So I just move this stuff to the left-hand side, and then yeah, we're gonna get the v in the left-hand side alone, but I just put x in the bottom and then multiply x. That's eventually equal to v. Okay. So now then what yeah, so I mean mm, okay, so I mean yeah, so okay, you can just yeah, this just let's say x times, okay? I don't want to make you confused, okay? Just leave it. That's fine. Okay. So now I'm plugging this one into the differential equation right there. So then we're gonna get x times and dv and dx, and then plus v is equal to v over 2 minus 1 over 2v. Or just you put this one in the here. Totally fine. Or 2v. Just this one indirectly. Okay. So I just completely changed the variable of the differential equation to v and x from the y and x. Okay. So now the dv dx gonna be the v squared minus 1 over 2v, and then minus v times 1 over x, right? So that then, right, okay, then dv dx is equal to v squared, and then minus 2v squared, okay, the minus 1 over, isn't it? Because I just combined two things, two terms. Okay. Then times 1 over x. Okay. So this is a function of x. This b. This is a function of x. This is separable. This is separable. Right? It's separable. So what are you gonna do? We use the method of separable. Okay. So move this guy to the left hand side, and then move dx to the right hand side. Actually, v squared minus 2v squared minus 1 is minus v squared minus 1, right? So that is equal to this is equal to minus v squared plus 1 over 2v, right? Okay. Anyway, so move this guy to the left-hand side. What happens? We're gonna get minus 2v over and then v squared plus 1, right? Times, and then dv is equal to 1 over x and dx. And then we take it over. Okay. So doing that, right? So if you're just doing that, what are you gonna get? We got this one. Left hand side gonna be minus natural log absolute value and v square, and then the second right here. 1 second. It should be minus hold on a second. V squared plus 1, right? Okay. And then plus c is equal to natural log absolute value of x, and plus c. We're gonna another c, right? But let's say that plus c includes all the constant integrations. Now what is v? V is y over x, right? So this is equal to natural log and then y squared over x squared, the plus 1 is equal to natural log absolute value of x and the plus c. Okay. Now, before just combining these two terms, let me simplify the quantity inside the integral absolute value. So minus natural log absolute value here, and then y squared, and then plus x squared over x squared. Okay. Ooh. So now this is equal to natural log absolute x plus c. Okay. Then it's gonna be minus let me see, natural log absolute value y squared plus x squared over x squared, then minus natural log absolute value of x is equal to c. This is equal to minus natural log absolute value. We just say minus. We can combine two guys, right? Y squared plus x squared over x squared times x, isn't it? That is equal to c. This is equal to minus natural log y squared plus x squared over x is equal to c. Okay. I don't think because you can simplify more. Maybe, yeah, let me just, decompose the fractions, but let me stop it, okay? So we got the implicit form of the solution, right? And then C will be determined by initial condition if the problems give you the initial conditions. Okay. So or you can say yeah, so natural log is equal to, I mean, move negative, multiply by negative sign on both sides, so we still got C, right? Because let's say negative C is nothing but C, because the sign of C will be determined by initial condition. Okay, then what? The e to the C, I mean, e to the C is equal to y squared plus, square plus x squared over x. You can say that. And then maybe you just isolate y. Y squared is equal something, blah, blah. Okay. But yeah, that's a way. Yeah. So normally we don't like the express the solution set involving natural log or sine, cosine, exponential form. I mean, transcendental functions involved. We don't like that. So, I think let me just stop here. Okay. So here the main idea is to using the change of variable to transform the homogeneous to separable.